Okay, so hello everyone. Today we will be discussing the post-contest analysis of Codeforces Round 1005 Division 2. In this session, we will be going over the first three problems and break them down step by step. So without further ado, let's dive into the first problem of this contest. And the first problem name is Programming Contest. Let me read the problem statement first. One day after waking up, uh, let's forget about this. We are given two strings s and t. We can remove some suffix from s and place it at the end of the t, or remove some suffix from t and place it at the end of the s. To win the programming contest, you must make the minimum number of moves required to make the s contain only zeros and t contain only ones. Find the minimum number of moves required. Okay, so let me explain the problem statement first. Let's copy this. Um, yes. So we are given two strings s, which is initially equal to 0 0 1 1 0, and t is initially empty. So our objective is to make s is completely filled with zeros and t is completely filled with ones. Okay, so in order to do so, we are given two types of operation, and the first operation we can do is to suppose this is a s, and the first operation is to choose an index from s. Then I can move all the substring from I till n at the end of the t. This is the first type of operation. Now my t will look like this. S is equals to 0 0 and t is equals to 0 0 1 1 0 0. Now second type of operation is I can select an index from t rather than s. So I will select an index from this 1 0 0. So now my s will become 0 0 1 0 0 and t will become 0 0 1. Okay, so I hope the question is clear to everyone. Now we are going to move the solution. Okay, so don't forget about the our objective. Our objective is to make s is completely filled with 1, s is completely filled with zeros, and t is completely filled with ones. Okay, now suppose that s will look like this. S is equals to 1 0 no, 0 0 1 1 0. Okay, now we need, according to our requirements, t is completely filled with ones. Okay, so in all ones which is already present in s has to be moved in t string, right? So we will select this one, this one, and this one, and this one, this one. All ones has to be moved in tth string. Then our requirements will be fulfilled, right? So we will apply an operation to observe something, right? uh, let me let me take smaller string so we can apply an operation. S is equals to 0 1 0 1 0 1. Okay, so this is our string. Now t is initially empty. We will select this index. What the hell? Okay, this index. Okay, now s becomes 0 and t will become 1 0 1 0. Okay, so this 0 has to be moved in s. So we will apply second type of operation in t. I will select an index, this index, and move all the substring into the s. Now s will look like this: 0 0 1 0 and t is 1. Now this one has to be moved in T, right? So we again apply an operation on this index. Now S will look like this: 0 0 1 1 0 T. Okay, so this is our last operation, and we need this 0 to be moved in S, right? Now 0 0 0 and T is 1. See, our mission is success. We filled T completely with ones and S completely with zeros. So by observing this pattern, we conclude that if Si is not equal to Si plus 1, if Si is not equal to Si plus 1, then we will increment answer by 1. Yes, this is the whole crux of this problem. But there is an edge case to this problem. But what if S will look like this: 1 0 1 0 1? Okay, let's say 1 0 only. Okay, if it is 1 0, according to our answer, Si is not equal to Si plus 1, the answer to this test case is 1. But the actual answer to this test case is 2. Now how it happens? Let's understand. We need T is completely filled with ones, right? And S is completely filled with zeros. Okay, so we will apply an operation. S, we will select 1, and now T will look like 1 0 and S is 0. S is empty and T is 1 0, right? Now 0 has to be moved in S. Okay, so now my S will look like 0 and T is 1. Our work is done. This is our first operation. This is our second operation. The total number of operation is 2. Okay, now let's move to the coding part. Uh, yes, the code is very pretty simple, I guess. Let's see. Okay, we will take the input length of string as n, and we will take the input string. We will run a loop from 0 to n minus 1. If Si is not equal to Si plus 1, then we will increment the answer by 1. If S of 0 is equals to 1, then we will increment the answer by 1. We will print the answer. Yes, that's the whole problem. Now we are going to solve the second problem of this contest, and the problem name is variety is discouraged. Okay, so let me read the problem statement. Define the score of an arbitrary array to be the length of B minus the number of distinct elements in B. As you can see the example. Okay, so you have an array A. You need to remove the some non-contiguous subarray from A at most once. At most once. Okay. More formally, you can do the following at most once. Okay, so this is the elaboration. Output an operation such that the score of A is maximum. Okay, so if there are multiple possible answers, output one that minimizes the final length of A. Okay, let me briefly explain the what problem is trying to say. Uh, First of all, let's understand what is the score of an array. Let's say array will look like this: 1 2 3 3 4 2 4 and 4. Now the score will something like, what is the length of this array? 1 2 3 4 5 6 7. 7 is the length of this array, and the number of distinct elements is 1 2 3 and 4. So total number of distinct elements is 4. total number of elements minus the number of distinct elements is equals to 3. This is the score of array. Now, to maximize this score, we are given an operation to perform this at most one time. Okay. So, what is the operation? Suppose there is an array elements A, B, C, D, E, F, G. We can select L and R in this array. Like we can select an index L and some contiguous rth index. Suppose I will choose rth index and I can delete an elements from L to R, and the remaining array will look like this: A, F, and G. Okay, so this is the operation. I hope the question is understand to everyone. Question is clear to everyone. So let's move to the solution. In order to solve the problem statement, first we will understand what the uh, how we can calculate the score of this array. Okay, so total number of elements minus distinct elements, right? Okay, right. So yes. Now, if I choose less number of distinct elements and more number of total number of elements, this will automatically increase my score, right or wrong? Like if I will choose less number of elements, distinct elements, and total number of elements is more, it will automatically increase my score to maximum, right? So in order to do so, let's take this example. uh, Now my array is 1 2 3 2 3 4 5 6 4 5. Okay, so let's say this is the first index. This is distinct. I will take it. Second, take it. Third, take it. And second. So in this index, there is not optimal to remove this because it will increase my answer. See, if I choose this, number of elements is 4 and number of distinct elements is 3. So it will increase my answer by 1 up till now. So it is not optimal to choose this index, right or wrong? Yes. So here it comes the conclusion part. We will choose the longest subarray of distinct elements. Longest subarray of distinct elements such that it will remove and we will give the maximum answer to the problem. Okay. So now I think the solution is clear. To implement this strategy, we will use the sliding window technique to implement. Okay, so let's move to the coding part. Yes, this is it. Yes, this is the code. We will take the input of vector and create a map, store all the frequencies of in map, and we will create a L and R function, L and R variables, initializing with -1 to store the subsegment, contiguous subsegment. Okay, so we will apply sliding window strategy. We will take j as maximum of j comma I uh, to move forward. While j is less than n, we will n map of v of j is equals to 1. It means that the element has frequency equal to 1. We will move forward, and this is it. J minus I is greater than length. uh, we will store the maximum length. Okay, so we will update the answer. L is equals to I, R is equals to j minus 1. J minus 1 because up till j. Okay, so j minus 1 we have to we have to move the backwards loop. Okay, so if L is equals to -1, we will count is equals to 0. It means the array will not exist, contiguous subarray is not exist. Then we will implement uh, L plus 1 and R plus 1. uh, Plus 1 because we will take the first base, 1 base indexing rather than 0 base indexing. Yes, that's it. Okay, so moving forward, we are going to solve the third problem of this contest. The problem name is remove the ends. Um, okay, so let me read the problem statement. You are given an array of length n consisting of non-zero integers. Initially, you have 0 points. You will do the following until a is empty. So the operation given to us is like that. If ai is less than 0, then we can replace a with 1 to a of I minus 1, and otherwise we can replace a plus 1 to m. Find the maximum number of coins uh, you have at the end of the process. Okay, let's dry run the test case and try to understand what the problem is trying to say. Yes, let me copy the note section as well. Yes. Okay. So we have to maximize the answer by applying two operations. The first operation is, if my a of I is negative, then I can replace whole array with the prefix of this up till I. Okay, so the now my array will look like this: 3, 1, 4, minus 1, and minus 5. Minus 9 will be removed from the array. Then I can add it to the whole answer variable. Okay, though, so second type of operation is, if my a of I is positive. Uh, as you can see in the second, my a of I is positive. Then I can replace my whole array with 1, 4, minus 1, minus 5, and add the answer to 3. Now my answer is 12 and my array is this. Now I hope you will understand the problem statement. Now we are going to move the solution. Okay, so for solution, let me remove this first. Let's suppose these are my array elements: A, B, C, D, E, F, G, H. Okay, so A is positive, negative, positive, negative, 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 positive, negative. Yes. Okay. So if A is positive, then I can change my whole array to B, C, D, E, F, G, and H. But if H is negative, then I can change my whole array to A, B, C, D, E, F, and G. So we can conclude that it is optimal to select positive at the first and negative at the end, because it will give my optimal answer to my problem. See, if I select my positive at the first, then I I have options to choose from B to H. If I choose negative from the end, then I have an option to select from A to G. Yes, this is the optimal strategy to choose from the front and negative from the back. Now, from this observation, we can conclude that first we have to select some positive elements, then we have to select negative elements to get the maximum possible answers in this problem. Okay, so how can we do that? Suppose there is plus, minus, plus, negative, negative, plus, negative, plus, negative, plus. So there are many ways to select positive, negative, positive, negative. Like I can select from this positive, this negative, negative, negative. So there are number of ways to select. But which is the optimal way to select? So here comes the concepts of prefix and suffix array. we can create prefix and suffix array to store the maximum possible answers up till I up till I from the prefix, and from the back we can conclude this into a suffix array. Yes, let me show you the code. This will be much better if I show you the direct code. Okay, so just a minute, guys. Mm, okay, so this is the input array. We can create prefix and suffix array. If v of 0 is positive, then I can assign prefix of 0 is equals to v of 0. So I will run a loop from 1 till n. If then I can conclude prefix of I is equals to prefix of I minus 1. It means we are going forward with the prefix of I minus 1. If v of I is greater than 0, then I can conclude into a prefix of I. So this is the same part for the suffix. I can do this same part for the suffix array from the back. Then we will calculate the maximum answer by adding prefix of I plus suffix of I and stored it in max variable. Yes, that's it, guys. So today we solved three problems of Codeforces round 1005, and I will share the solution video of these three problems in the description box. Okay, thank you very much, guys.